My name is Scott Irwin. I'm a senior software engineer with Bloomberg. And we're here to talk about data classes. So data classes are here, but now what? What do we do about them? So let's talk a little tiny bit about what we're going to cover. I'm going to briefly cover what is a data class. We'll talk a little bit about some of the basic features. We'll talk a little bit about some of the additional features that are available in data classes. We'll compare data classes to some of the existing data structures that are available in Python, and then briefly cover some guidelines for when and how you might want to use these. So first of all, what is a data class? Well, at its heart, a data class is a normal Python class. But it is one that's kind of intended as a data container. Because it is a normal class, it has the same memory and speed as any Python class. From the PEP, the guidance here is to think of a mutable named tuple with default values. So a quick background. Data classes is a module. It was added to the standard library in Python 3.7. It was written by Eric Smith, and it's described in detail both in the Python documentation for 3.7 and in the PEP 557, which proposed the addition of data classes. A few more details is that the module really includes two things that are of broad interest. One is the data class decorator itself, which this is used to generate the special methods for your class, otherwise known as the dunder methods. And then a second thing is the field function, which is used to define fields within the data class beyond the simple case. And we're going to cover that in a minute. The field definitions themselves do rely on variable annotation, and that was introduced to Python in PEP 5.2.6. So what are the basic features of a data class? Well, this is a data class right here. I've imported data classes, and then I just use the decorator, and then this is my class. From that, I am able to instantiate an instance of my class very simply. But what's missing here is that if I try to construct one of these without providing the required inputs, I get an error. So data classes provides a very easy way to provide default values. You just do it in line where you define the fields. So going back to our previous example where we create a point without any arguments, we get the default point. And then I can also partially define what I want. I can specify some, but not all, of the fields, as in the example on the bottom. And again, because data classes are just a normal class, in addition to having the fields, I can define arbitrary methods in my data class. And here I've defined a method distance2. Now this is Python. We are a dynamic language, and the types are hints. So while I've said I expect these to be an int, there's nothing in the language that enforces that. So here I've created a point using floating, and here I've created a point using string. And the language is totally fine with that. Accessing the fields in the instances of a point is the same as any attribute on a class. I use the nice convenient dot syntax. We want to understand what this decorator is doing for us. So at its heart, in its default usage, I'm getting three methods that are getting added to the default, or getting added to a simple data class. I'm getting a dunder init, I'm getting a dunder repr, and I'm getting a dunder equal. And we saw an example of the dunder repr in these examples here where I am printing out. I didn't notice I don't have a string representation here, but I'm getting a nice string output for free. And that's coming from the decorator. Here's what, for that point class, this is what the generated code basically looks like. And it's what you would write if you were implementing this class fully yourself. So I have my two attributes. I'm setting those on the object. I have my string representation, and I have my dunder equal method, which is, and the way that the data class does this is it takes the attributes in order, puts them in a tuple, and compares that to a tuple from the data attributes from the other object. And it does put in the nice check to make sure that it's doing an equality check between things of the same type. So now that we understand, at least at a basic level, what a data class is, let's take a look at some of the additional features. So the data class decorator actually is a decorator that can take arguments. And these three usages of data class are equivalent. They all do exactly the same thing. So I can use the at data class with no arguments, with 0 arguments, or with these 3 arguments, which are the default values. The decorator itself actually takes 6 arguments. There's the 3 that we've already seen, init, repr, and eq. It also has order, frozen, and unsafe hash, and we're going to touch on these in just a second. Ordered is where you have a data object that has an implicit order, where less than, greater than makes sense. So I can define my class as being ordered. I said ordered equal to true, and I will automatically get these 4 dunder methods defined within my class. And they will do a similar thing to the dunder equal, which is they will take the attributes in order, put them in a tuple, and then do that corresponding operation between the 2 tuples. And here we can see an example of the less than, the dunder lt method for the point class that we saw earlier. Data classes also support immutability. That's what the frozen attribute is, or the frozen option is for. And part of that implementation is that it makes assigning to the fields an exception, a runtime exception. So if I declare that my data class is a frozen data class, I can construct one, but I can't mutate the fields subsequently in code. Finally, there is unsafe hash. The default value, as we mentioned earlier, is false. The data class decorator will give me a hash method depending on the values for equal and frozen. So if I have a frozen data class that has an equal operator, I will typically get a hash method. And there's a little bit complicated logic within the implementation to decide when you get one and when you don't. If the decorator has decided that you shouldn't get a hash method, but you as a designer of this class feel that it is appropriate, you can override that default behavior by using the unsafe hash and setting that to true. That said, the Python documentation is very clear that this is not recommended. It's there as an escape hatch if just somehow the decorator isn't doing the right thing for you. But essentially, if you set this to be true, it is forcing the data class decorator to create a hash function for you. There are some caveats that go with the decorator options. So if you recall, init, repr, and equal I get for free, or they're the default options which I get. if I, in my class, define a dunder init, then it doesn't matter what the init value is. Similarly, if I define a repr, a dunder repr function, the repr argument is ignored. And again, if I have a dunder equal, then the dunder equal option is ignored. And what this basically means is that I can use the naive at data class and have one or all of these defined in my class without having to step into the more complicated definition of the decorator. The other three, because the default value is false, I only get them if I opt in, but the decorator is going to try to protect you from doing something that is ambiguous or potentially dangerous. So if I set order to true, but then I go and start defining some of these order methods, the decorator is going to throw a type error at compile time, basically, at interpretation time. Similarly, if I set frozen to be true and I define either a set adder or a del adder, the decorator is going to do a type error. And lastly, if I insist on setting unsafe hash to be true, but I have provided a hash function, the decorator is going to throw a type error. Now, up to this point, we've only seen simple fields where I've defined a type and I've set that field equal to a default value. Well, what if my needs for fields are a little more complicated than that? And that's what the field function provides. So one of the things, or some of the things that the field function can do for me is that I can opt out of some of this behavior, this default behavior, on a field by field basis. So for a particular field, I can exclude it from the repr, or I can exclude it from the init, or I can exclude it from the compare. Probably the most useful feature available in the field function is the default factory, because that is what I have to use if I want to be able to set my default value to a mutable type. And we're going to see an example of that in just a second. One point for the default factory, what you're giving it is a function, and that function has to be a zero argument function, or has to be callable with zero arguments. So here's an example. I'm going to have a data class called book. It's going to consist of a title, an author, and the date that I acquired the book. So suppose I have a library, and then I acquire books from another library, and I want to make sure that I understand that I have multiple copies of the same book. I still want to track when I acquired the book, but I want to be clear when two books are the same. And so this is where I'm excluding from the compare this date acquired. And so here I have two copies of Moby Dick, one acquired in 2017 and one acquired today. They're still the same book, and the compare operator confirms that. Just a quick reminder of why mutable types as default values can get us into trouble. If we look back at keyword arguments or default values in just regular functions, if I naively put a list as my default value, I can get unwanted behavior within my function, because what it's doing is it's storing a reference to this list and then reusing that list in a mutable way each time I call the function. So data classes want to be able to provide you a way of, say, setting an empty list as your default value without getting you into this situation, and that's where the default factory comes in. So here I'm defining my library as a list of books, and I'm using the list constructor as my default factory. And this is just a little bit of code to show you that even though I have 2 library objects, if I add a book to one library object, it doesn't affect the list of books in the other library object. There are a number of other features within the data classes module. I'm not going to go through these, but I did want to highlight them to you. Data classes has a function as dict, which allows you to take an instance of a data class and render it as a Python dictionary. Similarly as tuple. If I have a frozen data class and I want to create a new instance of that object, but I want to mutate one or more of the fields, I have this function called replace. In addition to, and that name comes from the NamedTuple. These are basically reusing existing names from existing Python data structures. You also have the capability for post and init processing, init-only variables, class variables, and of course, because this is a Python class, you have inheritance. So how does this compare to some of the existing data structures? So I'm only going to work on or talk about things that give you some way of accessing fields by name, which is I'm going to leave out sequence or sequence data structures like list and tuple. So we have NamedTuple. Well, one of the issues with NamedTuple is it's designed to behave as a tuple in tuple context. It's immutable. It has no field options. I can't add methods to it. It does have a descriptive repr, and it's available in Python 2.6 and later. Python dictionaries, they've been around forever. I can access values by name, but as a key, not as an attribute. I can't set up default values. I cannot add methods, but it does have a semi-descriptive repr. Default dictionary solves the default value problem, but it's at the whole dictionary level. I can't do it at an individual field. It's the whole dictionary has this default value, and that's it. I could write my classes by hand. I mean, after all, a data class is a class. Equivalent memory, equivalent speed, but writing the class myself is more work because I have to write more code and I have to write tests for that code that I've written. Lastly, I want to mention handwritten classes using slots. Slots do have a slightly smaller memory footprint compared to a standard class. Because of that, they also have a slightly faster object creation, and the attribute access is slightly faster. You could consider it a bug or a feature. If you create classes with slots, you can't add additional attributes to the objects at runtime. And again, similar to a regular class, I have to write all of that code, and I have to write tests for all of that code. Lastly, there's attrs. Attrs is not part of the standard Python dictionary, but it provides essentially a superset of the features available in data classes. It does have a slightly more verbose syntax, and I do mean slightly. And it has additional features such as validators and converters, and it was one of the inspirations for data classes. And it also, for those of us that still have to support Python 2.7, it has support for that. So when do I want to use data classes? Well, when I need a mutable data holder. Also, I can use data classes when I want or need the dunder methods that it generates, but I don't want to have to write them myself. When do I not use a data class? Well, if you have to support any Python versions prior to 3.7. This is a feature that was introduced. That said, Eric has provided a backport that's available via pip that works in Python 3.6. Another situation where you might not want to use data classes if you have to provide API compatibility with these other basic data types. Or if you need extended features such as value validation or conversion or type validation. So in conclusion, data classes are new in Python 3.7, but the idea has been around for a while. Data classes as they exist in Python 3.7 were described in PEP 5.5.7. And the bottom line is they reduce the effort needed to implement user-defined classes. And the decorator and the field function automatically add these special methods or the dunder methods for you. Resources out there, the Python docs themselves, the PEP, which describes these. Raymond Hedinger in PyCon this year had a talk on data classes where he looked at it from a slightly different perspective. He called it the code generator to end all code generators, and looking at data classes as just a way of making writing classes easier. And then finally, these slides are available on GitHub at this address. So thank you.